This tutorial will go over how to import a sample of microtomography into PuMA. There are three basic steps to this process. The first is to take the TIFF stack that was generated using the instructions in the last tutorial and load that into PuMA. The second step is to import a subdomain of that into memory, and the third step is to select a threshold. Now for step one, loading a TIFF stack into PuMA, there are two different ways to do that. The first is to use an image list, which was explained how to create in a previous tutorial. You can select the image list and the TIFF stack will automatically be uploaded into PuMA. The second option is to load the images directly. If the images have the naming scheme of image underscore and then a number that goes serially upwards, then this method can be used. You simply have to click on the first image of the image stack and it will automatically upload it. Now the next step is to import a subdomain for extraction. Now this uses the C++ indexing notation, meaning that it starts at 0 and it ends at n-1. If, for example, we used 800 here, this would be out of bounds. For the purposes of this tutorial, we'll select a 400 cubed sample and import that into memory. As you can see, a red box will appear around the selection, which will show you what is and isn't captured in this subdomain. Finally, we'll put the voxel length of 0.65, which is the case for this microtomography sample, and click Import. At this point, the selection will be expanded to the full image here. If you want to see how it compares to the original image, you can use the Revert Crop button to go back and forth. At this point, a probability distribution function of the grayscale values is shown here. So as you can see in the image here, this is an 8-bit grayscale image, which means that every single pixel, or for in the 3D case, every single voxel, has a value between 0 and 255. What we have to do is choose a threshold at which anything at or above this value will be considered solid, and anything below this value will be considered void. Now you can see here that there are two different peaks in the histogram. The first peak here indicates the average value of the voids. The second peak, which is harder to see and more spread out, is here, which indicates the average value of the material. We have to select a grayscale value that is somewhere between these two peaks. Typically, it's at this inflection point right here. So for this particular TIFF stack, a value of 87 was found to be correct. Now, once you've clicked Select Threshold, this will appear as a binary image. You can revert back and forth between the original and the thresholded image to make sure that all of the details of the original image are being captured sufficiently. If you want to experiment with a different threshold value to see if that's correct, you can repeat the process. If we take a value that's too low, for example, we can see that we have a number of things that are considered to be material that when you look at the actual image are not. And if you choose a value that's too high, say 120, you can see that we have a lot of voids that are now within what is pretty clearly material. Now the reason this thresholding process is difficult for the carbon fiber preform microtomography is that the carbon has very low density and there's a pretty complex internal structure. So it can be difficult to get a good tomography image that can be segmented easily. However, with a threshold value of 87, this sample is able to be thresholded reasonably well. At this point, the tutorial on microtomography import is complete. For calculating material properties or running oxidation simulations, refer to the subsequent tutorials.